Hello everyone, so welcome to my channel. So now it's its turn for our third question of our today's lead code weekly challenge. So let us go to it that how the question is. So check if there is a valid partition for the array. That's the name of the question. So according to name only we can check that we are required to figure out a valid partition, and surely there would be some condition for this valid partition. So that is all what we would be doing in this question. So you are given a zero index integer array num, and you have to partition the array into one or more contiguous subarrays. So this is the thing which we need to keep in mind, that it should be contiguous in nature. So now we call a partition of the array valid if each of the obtained subarrays satisfy one of the following conditions. So here are the conditions which we are required to check. So first condition, the subarray consists of exactly two equal elements. So first condition is this, that if it satisfies this condition, then it is a valid partition. So for example, 2 is good. Now subarray consists of exactly three equal elements. For example, 4 is good. Then a subarray consists of exactly three consecutive increasing elements, that is the difference between adjacent element is 1. So even if the elements are in increasing order, still then at that moment also they are good to have. And for example, 3, 4, 5 is a good one for considering in a valid partition, but 1, 3, 5 is not, because the difference is of 2. So now we are required to return true if the array has at least one valid partition, otherwise we will return false. So this is thing which we are required to do in this particular question. So now comes the part that how you would be doing this question. Then we are required to check either there are two equal elements, or there are three equal elements, or there are three elements which are in increasing order. So according to this only we are required to partition it. Now here in the first example, 3 4s are there, right? So this is in the one of the conditions of our given ones, right? And then we check 4 5 6. This is also in one of our condition which is given above, right? So 4 5 6 is in increasing order, then 4 4 are all three equal elements. So yeah, we are required to return true that yes, it is a valid partition, and that partition is at this particular 4, means middle one 4, means the last one 4 basically. So that's the thing. Now in this example, you can see that at the first sight I also thought that 1 is a valid condition, and then this 1 and 2 is also a valid one. But the thing is that it's not 1 and 2. If we are required to check for the increasing order, then the thing should be that there should be three elements. Then only we'll consider for the valid increasing sequence. But here it is having three, it's all right, but it is having only two elements. So that's why we are required to return false. So that there is no valid partition in this particular. So according to this, now what comes to your mind? The only thing which comes to mind is that we are required to keep a check it at every point, that till now is it a valid point or not. That's the thing which we will be doing in this. Means at 4 we'll check the first one is always a valid one, right? Means say for the case if we are having only two elements, right? So in that two elements, what we'll check, we can only check that if they are equal or not, because there we can't check for the increasing one, right? Then it is already invalid. So that's why first we'll always take the true. So at first point we'll check the true, and then at the second one, what we will be doing is we'll check that if they are equal or not, then only we'll make it true. Then at the third again we'll check if it was earlier valid, till now it was valid, then only we'll make it as valid, else we won't make it as valid. That's the thing. Then at this fourth index, what we'll check? We'll check that till now all were valid or not, and then we'll also check that are they equal or are they increasing. Then according to that only we'll go ahead and make it valid or not valid. But here, yeah, all were equal, So that's why we'll consider it as valid. But what is the relation of this particular with the previous one? That is that it is an increasing order, right? So that's why only at that moment only we'll just check that it is valid. Yeah, it is. And at the 6th, we'll again check that what the previous ones were valid or not, and what is the relation of this particular with the previous one, right? And then only we'll make this as the valid. So this is thing which we would be doing here. And according to this only we'll devise a solution. So it is somehow like, don't you recognize this pattern as that we are required to do DP here? Means we are required to maintain a particular state, do a transition according to the fact that what was the previous state, right? So that's why this particular question is a DP question. So now, before coding up, I want that you should think and code this by your own, that how you'll come up with the DP question, DP solution, because I've already given you the valid points that how we are required to check for the previous, that how they were and how we are able to recognize and how we are able to start. And even I have explained you all the edge cases, that for the 2 array size, 3 array size, these are the 2 edge cases which we are required to figure out separately. So that you are required to do. So yeah, because if you are able to code now, then only you will be able to do in your interviews, right? So yeah, and one more thing, some interviews I recall that as some of the students were asking about that they require a structured course with one-on-one mentorship and even live doubt solving. So you could consider for that for the Newton School. And this channel is also supported by Newton School only. So yeah, you could find every detail of the Newton School in the description itself. Link of the website would be there and everything. And the best part which I recognized about the Newton School was that when you enroll in the course, you don't need to pay any upfront fee. You are required to pay all your fee after you get placed, and they give the package from 5 LPA to 40 LPA. And when you get either of them through their course and their placement program, then only after that you are required to pay the fee. So yeah, this was about that course which I would recommend for you. And now comes the part that how we are required to do this coding. Now here's the thing. Let me show you the whole code that how we are required to do. So here's the thing is that how, let me start one by one. At the starting, we will check for, because we are required to maintain that is it valid or not. So that's why we are taking this vector bool valid array, basically a vector, which now we have formed it into a array by initializing every value with false, and the size is n. Now comes the part for the array of 2 length. We'll check that are the previous one equal or not. If they are, then only we'll make our valid one equals to true, and if n equals to 2, then at that moment only we'll return our answer. Now comes the part that if it is of size 3. See, there was a case that if it is of size 3, then only we can check for the increasing order, right? So yes, here we got the size 3. So in this we are required to check for the 2 cases, and out of them 1 case is of checking that all of them are equal or not. If all of them are equal, then only we'll return true, and if all of them are in increasing order, then only we'll return true. And this is the thing we are doing. And then at the end we'll return valid of 2, which will be having our answer only when our array is, means input array is of size 3. Now here comes the part when we are having array of above length 3, right? So in that scenario, what we would be doing is, so here we will check that if nums of I equals to nums of I minus 1 and valid of I minus 2 is there. Basically this is for the 2 equal elements. In that criteria only we'll check, and we'll also check that valid of I minus 2 is true or not. That we are checking so that we could be able to understand that were their previous ones which are valid or not. If they are valid, then only we'll move ahead and make this also true. If that was not the case, then then this condition would be false at that moment. Now comes the part that for the three elements. Again, we are checking that if they are equal or not, and also checking that valid of I minus 3 was valid or not. Then only we'll make this particular as valid of I equals to true. Then here we are checking that if they are in increasing order, right? Because now there are more than three elements also, but we are considering for the last three elements. And then we'll check that if it was there, means again valid of I minus 3 was true, then only we'll make this particular as the true. So this was the thing which we were doing here. Now at the end we'll return valid n minus 1. Why we are returning valid n minus 1 and why not n? Because if valid n minus 1 would be valid, then at that moment only we can make our n as valid, right? So why don't we return that n minus 1 itself, right? Because we already figure out one valid partition, right? So that's why we are returning with valid of n minus 1. So this was all for this particular question. If you have any doubt, you could directly comment that down. I hope you like this video, and please do like and subscribe to my channel. Thank you.